Hello and welcome to Algebra 1 Honors. This is lesson 7-9, which deals with negative exponents. Now what are we talking about when we say a negative exponent? We're talking about a number that looks something like this. 2 to the negative third power. Okay, that's what's called a negative exponent. Okay, now we probably have never been able to solve a negative exponent in this form. And that's very true because when you get to a negative exponent, they're handled in a special way. But once you learn this way, it becomes very, very easy to deal with a negative exponent. So the very first thing that you need to know about a negative exponent, in this form, 2 to the negative third, I don't know how you take a negative third power of a number. But we do know that if you have a negative exponent and you take the reciprocal of the number, take the reciprocal of 2, which is going to be 1/2. Okay, your exponent changes from negative to positive. It's sort of like if this line was the equator. When it goes below the equator, whatever its sign is, if its sign was negative, he's going to pop up and be a positive because he crossed the equator and changed his name. If he happens to be a positive and he crosses the equator, it's reciprocal, he's going to turn into a negative exponent. Okay, so we can work back and forth, back and forth. All right, so let's look at this. Now we've got something that we've seen before. 1 over 2 to the third power, which actually means 1 over 2 times 2 times 2, which is 1 over 8. Okay, and that's a number that we recognize. All right, and that's how we do every one of these problems. Okay, now the rule for this says this, and this is the generic rule for negative exponents. It says if you have a to the negative n power, okay, to be able to solve this, you take the reciprocal, which is going to be 1 over a, and we write it like this, 1 over a, and we change its sign to a positive. Okay. Now let's work a couple more of these problems, and then we'll move on. Okay, so you should be ready to convert. If I had 5 to the negative fourth, okay, I'm going to put two problems up here. 5 to the negative fourth power, what could that equal? Okay, and what if I put something like this? 1 over 2 to the negative second power. Okay, both of these look pretty strange and pretty odd because they deal with negative exponents. But if we follow our simple rule, which was this, a to the negative n power, okay, equals 1 over a to the n power. We change our signs. We can easily do this. Okay, if I take this and I take the reciprocal of 5, it's going to be 1 over 5, and I change my power sign to the fourth. I'm going to have 1 over 5 to the fourth power, which actually comes out to be 1 over 625. That's a big number. Okay? And conversely, let's look at this guy. You see I have 1 over 2 to the second power. If I'm going to change him, I take the reciprocal, and instead of 1/2, I'm going to have 2. I can have 2 over 1, and my exponent is going to change to 2, and my answer for this guy is 4. And so you can see that this form here is just a fancy-dancy disguised way of writing the number 4. Okay? Now, we're going to have a quick review here of the different rules that are used in using exponents. Okay? We've gone over, but we're going to collect them all right here in one place, and we're going to go over them. Okay? And the very first rule that we have, is the product of powers. Okay? Product of powers. All right, well, we're kind of familiar with that. We've been using that quite often, and all it is this. Okay, and we're going to put this as number 1. Okay, the product of powers says this, that if you have two terms that they have the same base, b to the m times b to the n, okay, well, the product of powers says that we can say it's going to be b, and then we add our exponents together. So it's going to turn out to be b to the m plus n. We see this all the time when we're multiplying. All right, let's look at this. What if I had this? They have the same bases. 2 to the second power times 2 to the minus 3 power. Okay? All right, according to the rule, it says this, that we add our exponents together. We could keep our base, which is going to be 2, and we add our exponents together. 2 plus a negative 3. So the answer for this guy is actually going to be 2 to the negative 1 power. Now, we just completed discussing what that means, to the negative 1 power. So to get that exponent from being a negative or positive, we take the reciprocal of 2, which is going to be 1 over 2. Change the sign of our power, 1 over 2 to the first power, which actually comes down to being 1/2. Okay? All right, so that is called the product of powers rule. All right, let's look at the next rule that we have on our list. And that one is called the quotient of power. Okay, let's put number 2, quotient of power rules. Quotient of powers. Okay, and what that does, that says, instead of multiplying two numbers together, we're going to divide them. Okay, what if I had b to the m power divided by b to the n power? Exactly the same thing. If we have exactly the same bases, what we do with our exponents, instead of, when we multiplied, we added exponents. So when we divide, we do the opposite. Okay, we subtract them. Okay, the inverse operation. So in this case, we're going to end up with b to the m minus n. All right, let's write down a, let's write this, 6 to the minus 3, or let's just make it a plus 3. 6 to the third power divided by 6 to the, let's say, fifth power. Okay, now our rule says because we have the same base, we're able to rewrite our base and subtract our exponents. So we're going to have 3 minus 5, which is going to give me 6 to the minus 2. Again, we know how to deal with a negative exponent. Okay, here again we have a negative exponent. Okay, this is the right answer, but it's not truly in the right form. Most of the time, the right form is to have a positive, unless they ask you. They may ask you for the negative exponent. But in this case, we take the reciprocal, which is 1 over 6, and we bring it down and change its sign. So the answer for this guy is 1 over 36. Okay, so that's the quotient of powers rule. All right, well, we got a couple more to go. Okay, let's look at the third rule. Okay, the third rule is the power of a power. I usually call this a power rule, but your book says it's the power of a power. Well, that's pretty nice. Power of a power. Okay, what does that mean? Okay, all of these nice little rules. Well, the power of power just says this. If you have something that looks like this, okay, you have a variable or you have a number to a power, and it's inside of parentheses, raised to another power, could be a positive power or negative power. All you have to do is you take that power and you multiply these two together, m times n. Okay, I call that the power rule. They call that power of a power. Okay, so if I had something like this, okay, inside I have x to the minus 2 power, okay, and I had minus 2 on the outside here. To solve this problem, I would say, okay, well, it's going to be x to the negative 2 times negative 2, or x to the 4th power. Okay, that's the power rule. Now, a little something that I want you to understand about the power rule. What happens if I had a number in front of my x? Let's just pretend instead of having this, I had 2x to the minus 2. Okay, and then I'm going to raise it to the negative 2. We do the exact same thing, but we have to realize that each one of these little terms here has an exponent. The 2 isn't written, but it's actually 2 to the first power and x to the minus 2. And so we can't ignore a number in front of a variable. We have to address all, whatever's inside the parentheses. So in this case, what I would do is I would say 2 times 1 times negative 2. That would be one of them. And the other one would be x times 2 times negative 2 times negative 2. And my answer would come out as 2 to the minus second x to the fourth. Now if I wanted to write that in all positive exponents, I'd have to send this guy south of the equator. I have to take its reciprocal, which would be 1 over 2 squared. And on top, I would have x to the fourth. And answer would be x to the fourth over 4. Okay, and that's what we call the power of a power, or the power rule. Okay, let's look at the next one, which is called, this next one is called the power of products. Okay, let's put number 4 here, power of products. Okay, power of products says this, that if we have two products, well actually that's what I showed you just a minute ago as an example. If you have a product inside of your parentheses, such as a times b, and you're raising it to the nth power, okay, what you're going to do is you're going to multiply each one of the exponents, because there's a 1 here and a 1 here, and your answer for this guy is going to turn out to be a to the m power and b to the m power. Okay? And the last one is the power of quotients rule. Okay? The power of quotients rule. Okay, in this rule we're going to be dividing. Okay? We're going to be dividing a divided by b, and then we're going to have our exponent out here. And all this rule says is that each one of these guys has to be multiplied by the exponent. All right, inside we have an exponent of 1 here, an exponent of 1 here. So I have to multiply the top one, a to the m power, over b to the m power. And that's the power of quotient rules. Okay? And let's just do 2 examples and see if we can do them. All right? There's 2 examples of exponents. And we're going to use some of these rules, or maybe we're going to use most of these rules. But they're very important, and you should understand and be able to use them without any difficulty. All right, so let's look at a problem. I usually take the last few problems out of the book here. And so this is problem number 49. Okay, let's look at number 49. A squared times a to the minus 5th to the 2nd power. Okay, well this sort of looks like the power of products rule. Here's our power of products. But in this case, we can do it 2 ways. All right, and I'll show you both ways. We can go ahead and multiply each one of these. So this guy would be a to the 4th times a to the minus 10th, and when we add them together, we get a to the minus 6th. Okay? Or, that's one way to do it. Or what if we handled what's inside the parentheses first? Could we do that? Yes, we could do that. So a to the 2nd, a to the 5th is actually going to be a to the 2 minus 5, which will come out to be a to the minus 3. All right, and then we're going to multiply that by 2, and what do we get? We get a to the minus 6. So I hope that you realize that there's more ways to skin a cat in mathematics than just one way. Okay? You choose the way that you like, the way that you understand better, and then go with it. Okay, here's the last one that I have. Okay, this sort of uses, okay, this one uses the quotient of powers. Okay? Let's look at this real quick. If I have c to the negative fifth divided by c to the second, and what they're probably going to tell you to do is we want all exponents positive. Or conversely, they could tell you, I want all the exponents to be negative. We'll do it two ways. Okay, if I want all of them to be positive, all the exponents to be positive, let's see over here, we want all the exponents to be negative. Okay, just the flip side of what we do. All right, if I want everything here to be positive, I've got to take this c to the fifth power, and I've got to make that negative 5 positive. And to do that, what I do is I put a 1 up here. Make sure you put a 1 up here because you're taking the reciprocal of it. Okay, if you don't put a 1 up there and it's blank, you may be tempted to put a 0 in there, or who knows what you might be putting in there. So we take the reciprocal of this guy, which is c to the fifth power. Okay, and then on the bottom we still have c to the second, and we add them together, we get c to the 7. And that's the answer if they're all positive. Now what if they're, I say, maybe I'm having a bad day and I tell you, make them all negative. I feel kind of negative today, so make them all negative. All right, so you come back over here and say, well, this guy's already negative. I don't have to do anything with the c to the negative fifth, but I got to do something with him. So if I take the reciprocal of this guy, I'm going to get this. C to the negative fifth times c to the, this guy's going to come up as negative 2, and I'm going to add them together, and I'm going to get c to the minus 7. Okay, and you can see this is the answer, 1 over c to the 7th positive and c to the minus 7, and you would expect that. Because if you took the reciprocal of this, you would get c to the minus 7. If you took the reciprocal of that, you get 1 over c to the 7th. And that's it for lesson 7-9.